Hey, and welcome back to Crafting a Crawler. Jumping straight in today, as apparently I didn't have my intro scene set in OBS, but oh well. So yeah, carrying on from last week. Well, what did we actually get up to last week? We refactored a bunch of our map. We refactored a bunch of our map, and we cleaned up our objects, our game object stuff a bit. So, and then we were going to look more at extending our map this week, I think. So let's have a look where we are with the game. So if we run the game, we've got our new slightly fancier map. I still haven't had a chance to come in and finish off all of the tiles, so we've still got a few missing, like over here. Pretend it's not there. But one thing we do have is that we are very zoomed out, I feel. And the camera of the map doesn't the camera of the game doesn't follow you around as you move. So I feel like we kind of want our little player sprite to be in the center at all times. We probably want to render things, maybe zoom in like 200, 300-400%. So we'll have to have a quick look and see what we can do with that. So if we close the game window, I think what we're missing is a camera. And how this will work is there is some stuff that I was looking at in the wiki where we have a what did they call it? Well, we have the coordinate system. We push and pop onto that. So I think we need to push a new sort of coordinate system onto the engine, and then we need to translate, which will sort of set our offset, and then we need to scale. And then we need to scale to get the more zoomed in approach, if memory is serving me right. And then what we will do is we'll have the coordinate system sort of adjust a bit to reflect where our player is in the world. So yeah, if we let's have a bit more of a read of some of these. So push, pop, and we want scale. I think translate. And there's also apply transform, which is new. So I feel like this way we would be able to specify a bunch of this in once. No, maybe that's not what we want. Okay, so we've got translate. So translate changes the offset of the screen on the X and Y axis. So if we call translate 1010, then we'll get then when we say 5, it will actually add 10, and if we said minus 10, then it would have saying something to 5 would actually be minus 5. So that gives us a a place to start, I think. And then scale, I think, is we pass in a 0 to 1 sort of value that will represent the percentage we want to zoom by. Okay, so, and then to add to that, just to keep it tidy, we've got the pop and the push. And push allows us to save the current state. Then we can make our changes, and then we can go back to our important state, back to our previous state, which is important because we'll need that for drawing like the HUD of the game. So all the user interface and stuff, none of that is affected by our camera. Otherwise, as we walk away, our inventory will be left somewhere on the map. The screen will be left somewhere else on the map, and we won't be able to actually interact with it. So I think with that, we're gonna have a look at well, actually, let's hack this directly in. So if we do as we've done so far, we'll go messy, then we'll clean it up, and then we'll come back to it. So I think love.graphics.push is our friend here. And then at the end of this, we go love.graphics.pop. So, and then inside here, we should be able to go love.graphics.scale, and then yeah. So let's give this a quick try and see how this reflects in our game. So when we run it now, okay, that's cool. So we've now got we have weird artifacts in our tiles. That's a interesting new problem. So if we go to if we set this to 3.3 and then we run again, then we get an even more zoomed in look. Okay. I think maybe 2 was twice as zoomed in was good enough. All right. So we're also going to need a reference to our player. So we'll set that up there, and then here we'll go player is equal to we'll instantiate it, and then we'll save that, and then when we are in here, we want to translate the coordinates. So I think here we can go player dot player has a position, and we want the X, and we want the Y. Okay, yeah, and because player can be null, we want if player then end. I think we'll set this, we'll say type of this is a player. So what I did off camera is I also went through our traits, and I annotate them all as objects and classes. So we have types for each of these now. And then I annotated our actual objects to extend the various traits that they are made up of. And this means we can actually sort of see, we can use them to get some hints back while we're building things. So if we come and have a look back at where we were, so if I tell that this is a player, I think like that. Yeah. Then when we look at our player here, because we've checked that it's not nil here, we now know that the player here is actually the player object, and we can sort of have a look at what the properties are on there, and we can see this is our vector2 class, and we can see that this is our X. Okay, so now if we run this, see what we get. Okay. That's not what we're after, but things are moving as we move. Okay. Okay, that's interesting. I think what we may be seeing is ordering. Is an ordering problem. So here we're saying that all of the changes are twice what they should be, and then afterwards we're saying to move to where the player is. But I think we need to set the translate. So we need to set where we sort of move in the screen, and then we need to zoom in. Okay, so if we go and run this again, what do we get? Okay, still not quite right. So our player is moving. Player is moving faster than the camera is adjusting. Why would that be? Yeah, it's moving roughly twice as fast. So it's definitely the scale that's causing the trouble. Let's comment that out and run again. So, oh, yeah. Okay. I think we're also offset the wrong way. Okay, so this has given us a hint. So what I think is happening is these values are the wrong way. So we are moving in the wrong direction. So rather than moving our window across and down, we're actually moving it in the opposite direction. So if we give it another run now, oh, okay. So now we're moving around based on where we are in the top corner. Okay, that's an improvement. Okay, so then if we come back and we add the scaling back in. And then we run again. What do we have here? Okay, this is not what we're after. So I think maybe it was actually right before, and it was just looking weird with the transformation. Okay, yeah. Okay, sorry. So yes, because we want to make sure that everything is translated correctly, including the position of the camera, because otherwise it's going to be a smaller movement, I think. Everything else is being drawn at double size, so everything is being drawn at double size. So if we're moving at half, if we're moving at the previous rate, then we're moving across a smaller world, effectively. So yeah, this gives us some tracking on the thing on our little player there. So okay, but we're in the top corner, so we don't really want to be in the top corner. Sorry, randomly clicking. We don't really want to be in the top corner. We want to center things around our player. So if we come back to the wiki, we need to get the window size, I think. Is it the window size? Kind of need to get the screen size. Okay, that's not it. No, it's not those. Here we go. So this gets the width and height of the window. This gets the pixel width and height. I think we want get dimensions for now. So we'll call width and height is equal to graphics. Sorry, is equal to love.graphics dot get dimensions. And then I think we want this to be divided by width. Sorry, we want to subtract from this the width divided by 2. Let's subtract from this one height divided by 2. Wait. Right. It'll be add or subtract, but the quickest way I think is going to be to see what happens. Okay, so it was not, it was the other way. So with that in mind, okay, we're going to add there. Yeah, because we're negating the whole value, so it's actually because eventually we're going to unpack some of this and it will live inside our camera class. So this is what we actually want. We want the minus here, but because of the negation, the minus was instead doing an addition. So then if we run it, okay, that's not right. Do we need the width and height after the transformation? No, so it's still not that. Okay, so if we take this, sorry, I'm breaking the code again. Sorry. So okay, so if we come back to just the positions, then we run this. Let's see where we end up now. And we've got our breakpoint here. So our width is 800, our height is 600, which tracks. That should be the size of the video. We set to 4 and 3. So we basically set our character in the middle of what was the map. When that is set, okay, so now we're offset so that our top corner of the map is where our sprite is sort of drawn from. So now we want to move this by half the screen. We want to move it by half the screen less than what we've moved it by. So let's have a... I'm also curious what we get inside here for the screen. No. Yeah, if we call get dimensions here, what do we get this second time? Have a quick nose at how this works. So if we run, yes, these are constant, and ignore all the transformations. These ignore the transformations, so we can get away with. I think we will need a scale. Is equal to 2. And we'll set this to the scale. And then this will be the width minus the width divided by the scale divided by 2. To get our x and y, let's let's see if we fix the x. We'll try. We'll solve for x first, and then we'll see what we get to after. Okay. So on our x-axis, okay, yeah, that was what we're after. So yeah, so so we have the width of the window, but the width is in the unzoomed in values. So then we need to divide that by the scale, and then divide that by 2 to give us half of it. So then if we take this, we can apply the same logic with the height to our y. And F5 to run. And hey, yeah, so now we're roughly in the middle. Because we're still going from the top corner of the sprite itself. So I guess the other offset we need is we need to this means plus the player dot position, no, player dot drawable dot no, we don't have the size there, do we? Well, actually, what we can do there is if we go to our player, yeah, if we go to the so I think that what we're after is in the when we draw it. That was from the texture atlas. We have so when we actually draw to the screen, I think we have the offset, yeah, the origin offset. So I think we need to adjust these two values to sort of draw in the middle. So when we look at this, we have x, y, then we have the rotation, which is nil. Then there's some scaling numbers, and then we have x, y, yeah, we have x, y, the scaling numbers, which will be nil. Sorry, we have x, y. Then we have the rotation. We have the scale x, the scale y, and the offset should be this is a quad. Do we have the size on here? Ah, hang on. Yes, we do. You have the asset size, okay. So we have self.asset size dot x and self.asset size dot y. Okay, so then if we run again, I think, yeah, I think we're now centered. No, we're still not centered. Ah, hang on. And that's because I'm making exactly the same mistake I just made. I think we need to negate those two. So let's put this all on separate lines because it's too long now and it's a bit unreadable. Okay, so F5. That is even worse. I don't, it's not so bad for now. I think we can leave. We'll add this to our to-do list and we'll come back to it later. Yeah. When in doubt, ignore it. But we have the starts of a camera. A camera here, I think. So with that in mind, we can come back to our camera module. And we're going to define the module. We're going to define the meta table. Index equals m. We're going to return m at the end. And then we want a function in here for a new camera. So function m.new. And then here we want to go local self is equal to an object and return set meta table. We'll set that to empty. Okay, and then for our actual camera, I guess we set the camera. That would be our love.graphics. Love.graphics.push. And then we unset it. We'll unset it there. We also want a m.set position. Is that, yeah, let's go for set position, and we want to set X and Y. Maybe we'll just call this function move. Oh. Sorry, This is the one of the hardest things in all of computer science is naming things as is well recorded. So what we'll have here is we can use our vector 2 actually. We don't even need a method for this, maybe. We probably don't even need a method for this, so we can go we will need a copy of our vector2 library equals require crawler engine vector2, and this will be a new vector2 at 0, 0. Yeah, I think that's what we need for now, and then we will also, as part of this, we'll take a scale, and we'll set the scale in here as well. Then when we push the coordinate system on, we'll go love.graphics.scale, and we'll go because this will take self. I'm not quite sure set and unset is the right terms. So, we can go with attach and detach, I think, because we're kind of attaching and detaching the camera. Set, I feel, feels more like it's going to actually update something on the object. So, whereas we're actually just sort of attaching it to the screen, I guess. So now we've got our graphic, we've got our scale, and then we want the transform diary. Translate, there we go. And this would be minus self dot position dot x. Let's add some annotations into this actually, because it's getting, that will help us with the rest. So this is a class called camera. It has a field. The field is what do we have? We have position, which is a vector2. We have scale. Oh, sorry. Scale, which is a number. So these two give us our value. So we have here the minus the x position and minus the y position. I'm just thinking, we also... Should this be pulling back the... Should this be pulling back the size of the window in the camera class? I think... It's not necessarily the worst thing, but it's not that clean either. But let's get it working first, and then we can always tidy up in the future. Yes, all set. So I think what we'll also add is a offset. So I think we'll do screen equals vector2.new get dimensions. So that'll give us the size of our screen. And then we're going to set an offset to a new no. So this will be the position plus the screen divided size divided by scale. So what we probably don't want to do is all of this math on every time we draw to the screen. We probably only want to do the maths when we change something. So this brings us back to this where we started with function m dot have a move to and we'll give this a position as well. Let's document this as well. So let's return a camera and takes the scale, which is a number. Attach. Detach. So that attaches the camera to screen and Is that not what I had? Alright, fine, we've got that. How do we name things in the other modules? Timer factory. So this will be a camera factory. And here we're going to set the position of the camera. The camera and the position is going to be a vector 2. It should be self.position is equal to position. Self.scale, self.screen. We need to add the screen in here. Oh, no, the screen is a vector 2. And the offset is a vector 2. Let's go with set position. So then we can call self.setPosition self colon set position with our new vector 2. Actually no, because it's not the meta table is not currently set up, so we want m.setPosition and we'll go self, we'll pass that in, and the new vector 2, and that will set our position and our offset. And the offset is defined as that is the negative version of the position, and then in here it should basically just be a case of going self to offset x and self dot offset y. So by doing this, we've now got our x and y positions are being updated as and when why is that failing? Where's our vector 2 module? So this is flagged as supporting add, subtract, divide, multiply, and division. That should also be divided by 2. The type system is getting a bit confused at the moment, so let's go. If we divide the screen by 2, what type do we get here? So we get a vector 2. Still consider vector 2. Let's still consider the vector 2. Okay. And then if we do still consider vector 2. But if we do this, it thinks it's a number. Okay. We can fix this. So we need to go back to our vector 2 class, and then we need to implement another meta method, I think. So meta methods. Oh, no, sorry, that's garbage collection meta methods. Meta tables, here we go. So we've got add, subtract, multiply, divide, power, mod power. Here we go. So UNM is what we're missing. Did we implement that at the time when we wrote this? No, we did not. So what we need to now do is URM. Is this right? No. Like that. Okay, and then we need to implement that. So this is the unary minus. No, where do we want to put it? We want probably with the other math operators, right? So what the unary minus operator does is it negates the value. So we're getting a value that is a vector 2, and we're going to return a. So this is going to be a yeah. So then we have function. This is on the meta table, and we're going to set UNM A, and then we will return a new vector with a, which is equal to a minus a dot x and minus a dot y. So yeah, Okay, so this will give us our, this means we now should now support negative vectors. So if we come back and have a look at our problem here, yeah, it's picking up correctly that it's a negative value, and then the this should actually work correctly. So this should give us our offset. This should give us our offset as a product of the other values. And then we can translate by that. We can scale by our scale, translate by the translate. Then if we come back to our main code, we're always going to have a value to translate by. And this should clean up. Okay, so we want local camera equals nil. Okay, so that's a camera. In our engine, we want to import our new camera module. Expose that out. So this will be engine.camera.new. We want to zoom in too. And then in our draw method, we can go camera.attach, and then camera.detach. And then in our update, we can go camera.set position to player.position. So, given that, let's give this a quick play now and see how it functions. Okay. Looks like a slight snafu in how that's working. Let's debug. So we attach. When we attach, we'll let's have a look at what we get for our values here. Oh, we don't even actually need to on that line. Let's restart that. So if we look at what we've got set, all right. So we have a screen of 800 by 600, a position of 400 by 300. So to put that in the center, we're going to minus 600 from the X. Which is, yeah, because that'll be 800 divided by our scale of 2, divided by 2 again, so that'll be 200, 400, so that seems legit, and then this will be 150, 300, which would be 450. So the offset looks to be the right values. We flipped the sign there. That's the problem. So we want to go half. We want to go the other way. So we so instead of adding the half, basically half the screen, we want to subtract half the screen. So we move the screen back a bit and put ourselves in the center. Okay, so with that in mind, we can give things a little restart. Hey, there we go. We have now got ourselves a working camera. Though this is a bit problematic. So when we get to the edge, the camera continues to go off the edge. So we probably want to stop ourselves from being able to do that. So with that in mind, what we probably want to limit it and constrain it. So I can think that let's then have a okay. Let's we're going to want to confine the what's visible within a rectangle, which is effectively the limit of the world that we're in. So I think what we're going to need is a rectangle class. So if we add a rectangle class. So we can add the meta class and then we want to return M. Is there not a rectangle class in Love? Oh, sorry. Is there not a rectangle class in Love 2D? So there's no like native rectangle class. This is what we get for going with Love. Love is a bit of a sort of low level building block for us to build our own engine on. If we've gone full-blown engine like something like Godot, then we would have got all this baked in for us. But we went this way for a reason, because we wanted to dig in. So we wanted to explore more of what was happening. So here we go. So with that, how are we going to do this? I think I want to allow some overloading of this, which is basically we have a function that has two different signatures. So if we go back to our browser window and we check out how the typing stuff works. Somewhere in here we should have, here we go, at overload. So this allows us to define a separate signature. If we are, let's put the end in there so it's at least syntactically correct. So this is our rectangle factory, and we're going to want a set of basic primitives on this. We're going to want an x, a y, a width, and a height. So we've got those. If we have defined those, and then this is going to return rectangle, and here we'll mark this as a rect2. And so actually, from that, I think we're going to have a position and a size. Require crawler dot engine dot vector2. So I think we're going to have a vector2 library here. The vector2 library here will be, and then we'll have a field which will be position, and that'll be a vector2, and then we'll have another field size, and that'll be a vector2. Because we use, more often than not, we're probably going to want the vectors rather than the raw values. silence the spell checker on that. This is vector 2, another vector 2, and is a rect 2. So because what I was thinking is maybe we could actually make this support both, so you could pass in x, y, width and height. But if I overload according to the docs, then we have overload fun. Then we have x is a number, y is a number, width is a number, and height is a number, and this also returns a rect 2. So is that, yeah, okay. Okay, so I feel like the overloading, so in some languages you can overload, by passing, effectively by having completely different parameters. I feel like the Lua type system doesn't really allow that. I guess I can see why. The language itself will allow it, it's just the typing system that is that's doing a lot of the heavy lifting and telling us when we've made a mistake isn't able to express what we're after, which is a function with two completely distinct signatures. So I guess we will go for for what we have. And we'll just have to convert things into vectors before we touch the rectangle class. Or we can add an extra sort of factory class apart from new. So an extra factory method apart from new that will handle it. So here we set the self, and we're going to go position is equal to position, size is equal to size, and that gives us a and that gives us a rectangle. This can be module vector 2, because we're not actually using it concretely within. We're just using a reference to one of the classes. Okay, so that's given us our rectangle class. Local rect 2 is equal to require and then there's our module. So what we want to do is have a limit, and by default that limit will be unset. maybe it's not a. Okay. I was thinking we needed a rectangle because we wanted to confine our sort of camera within that rectangle. So, hang on, if we so let's call up the our drawing program. Other window. There we go. Yeah, so let's file. New. Great. Okay. So what I was thinking is we're going to have our map. Where's it? So we have our map. What? Okay. So we're going to have our map, and then we're going to have part of the screen that we can see. So I was thinking what we need in a camera is we want to be able to say the camera can't go outside of this bounds, and we define the border of the map. But maybe there'll be points when we do, so we kind of want to be able to set each of these sides individually, which means our rectangle would have to support undefined portions of its geometry, which suddenly now doesn't sound so much like a rectangle. It's actually it's slightly different, I think. So although we might support setting it from a rectangle, we probably don't want to actually set it that way. So we probably don't want to actually store it that way. So we'll keep the rectangle for now because it'll come in useful. But we want to set the individual pieces differently. So if we come back to our camera, we're going to want to set so what we're going to want, I think, is a enum? No. An alias. Okay, simple alias cluster. Okay, so something. Sorry. So we're going to want a alias type, I think, that defines the edges. So top, bottom, left, and right. Okay, so we can ditch that. And then, okay, so then we're going to have a field, which is our limits. that is going to be, top is a, oh, top is a number, which way round do we actually want to go around in this? Hi Aaron, welcome in. We're looking at cameras at the moment. Oh, and sorry, I've still got the browser up, so hang on. So hang on, so where are we? So we've now got a camera hooked up, and we're following around, but we want to stop moving as we hit the edge. So as we hit the edge, we want to stop the camera so it doesn't show us all this horrible blackness at the edge of the map. So that is going to require, and we also need to come back and look at the artifacts here from the tiles. So I think that is actually a more straightforward fix. I think that is because it's a white margin instead of a transparent one. So actually, and then we need to constrain the camera. So that we're going to need limits imposed on the. We need limits imposed on the various sides. So we want field. I think we're just going to go clockwise round, starting from the left. So limits is going to be defined as a table, and we'll have left, which will be a number, top, which will also be a number. Oh. Let's define this separate because it's going. No, we don't need to do that. Sorry, I'm getting distracted. We have right, which is also a number, and we have bottom, which is a number as well. So these are going to be the limits of where we can move in the map. And limits by default we'll set to so we'll set it to a bunch of empty values. And then we'll have a function set limit. Top, no, left, top, right, and bottom. Maybe bounds is better. Yeah, I think bounds is a better term for this. So we're going to set bounds of the camera. No. Because we're setting a limit to we're setting the limit to the bounds of the camera itself. So actually, yeah. So we're setting we are setting a restriction on the boundary of the camera, which is actually the bounds of the world that we want to allow the camera to exist in. So in here we go self dot limits dot left is equal to left. Self dot limits dot top is equal to top. The right is equal to the right, and bottom is equal to bottom. Hi Sultan, welcome in. Welcome in. We are currently working on a camera class for our little game engine at the moment. Sorry, our little game engine at the moment. So we've got it sort of wired up and hooked up to the player at the moment. But at the moment it can overrun the side of the map, so we're looking to impose some restrictions on that at the moment. So here we have a method that will set those restrictions. And then when we set, I think in here we'll have to apply the boundaries. So let's have a look at let's go back to let's double check our tile map actually. So what do we have in terms of size on here? We have the map size, and we have the layers, the tile. The tile size is on there, isn't it? So I think maybe we need to, when we set the camera up here with a scale of 2. So then I think we probably need to actually keep a reference to our map for a second. So we set the map to a object, and then we insert that into our bad copy pasta there. Insert that into our list of objects. So, and then we've got the map here, and then we want to set our camera. We want to get the tile size of the thing. So I'm just refreshing. So we've got our map size, which comes from when we load it, we look at the width and height. And this is coming out of tiled. So this is the actual width and height of the map. So I think we need to store the pixel size of the map as well. Oh, no, hang on. We can just calculate this here because we have the we can look at the layers. Grab the first one. The layers should be. So we should be able to go map dot okay, no. So to make our lives easier, we're going to update our map class. So this is going to now grow a extra parameter. Which is a vector2. And then at the moment this is only called in one place, so in here we'll go vector2 dot no, we've already got tile size there. Okay, so we'll pass in the tile size into our map as well. And then the tile size is vector2 and that'll be the tile dimensions. So now when we set this up, we can go we can go local pixel size is equal to map dot map size times the map dot tile size. And then we go camera dot colon set limits, and then we're going to have 0, 0 pixel size dot x and pixel size dot y. Actually, let's go for size. So now we've got the now we've got that bound set. When we update the position, we want to confine that to. So I think now we can actually expand our vector2 class a bit. So I think what we can add is a we can add in some extra things. So we want to add some stuff to constrain the vector around, so that we can't end up in places that we shouldn't be. Bear with me for one second. I did have some rough ideas on stuff on this. It's in my notes. So where are we? Well, we are in. So we want, yeah. So I think what we want is to go, sorry, it's quite small. What we want is a set of methods to give us some to compare two different vectors and return the biggest or smallest. So let's start with the function definition. So we want a m dot min, which will be self and other. We want a function m dot max, which is self and other. Yeah, keeping these roughly in alphabetical order. So this will be the largest vector, and it's going to return the larger of the past vectors. And it's going to take self, which is a vector 2, it's going to take other, which is a vector 2, and it's going to return a vector 2 as well. Should be the largest vector. Oh, actually, hang on. I can't remember actually can't remember how we describe the return value. Oh, and this will be the opposite. So this will be the so this will return the smaller. Returns the smaller of the past vectors. Okay, so no, hang on, wait, this isn't. No, this is different. Sorry. I am off on a tangent here. Okay, no. We want to constrain the vector. What's the word? Clamp it? Clamp, yeah. So we want to clamp the. I thought I was keeping these roughly in alphabetical order, but it seems not. I'll put this one up here anyway because it's more akin to the normalized than the other one. So we want to clamp the vector, and that is going to give. For that, we're going to have self, min, and max. And this is going to vector within min/max bounds, and then we're going to want to we're going to want to have some values here. So we're going to have the self, which is going to be a vector 2, min and max, and then we're going to return and then we return a vector 2. Return a vector 2, which will be itself. We're going to update this, and we're going to do self.x is equal to, we have, okay, so the max of we have the minimum of max.x and self.x. But self.x is also going to be the min of the it's also going to be the max of the min.x and self.x. So we want to have, so if self.x is less than min.x, then we want min.x, otherwise we want self.x. And if that value is greater than max.x, then we want max.x, or we want the value that we just calculated. So yeah, that gives us our constraint, and we want to do that again for the y's. And that will constrain our vector to within a specific space. And that's m.clamp. Let's keep this consistent with the other parts. Constraint vector components with it to be within the the min and max. All right, and then for consistency, we'll also add a function m.clamped, which will be self min max, and this will be local copy equals m.new self.x self.y, and we return clamp copy clamp min and max. Oh, if we spell return correctly. Then we want to actually put a no discard in there, so that we error if the value is not kept, because one of the clamp is a okay. So clamp should be constrain to the past There we go. And then this will be in place. Constrain vector components to the past minimum and maximum values. So what this will do is give us what we've done is we've given our vector class the minimum value, maximum value. We've given our vector class the ability to sort of constrain its value to within a bounding box. So if we consider a vector well, if you simplify it down and consider the vector as just a position, then you're basically constraining it within a bounding box set by the top left and bottom right corners by two other vector 2's. And that gives us our sort of box for the that gives us our bounding box for the world. So then with that in mind, we should be able to then go we should be able to actually store the limits of the, so we should be able to calculate a bounding box and then constrain our offset within it. So if we want the minimum is going to be self screen divided by self dot scale divided by 2. It's going to, well, it's going to be a vector 2. So vector 2.new plus that, and this will be based on our limits. So we've got the self.limits dot left or 0 and self.limits dot top or 0. Okay, so this is adding two vectors. So so the OR is going to account for the fact that the left is not set. No, I was hoping I could do this with the vectors alone, but it's not going to be quite that straightforward. This is yeah. Okay. we had before doesn't, no, probably doesn't work. As I was hoping it would. Okay, no, we can work with this. So we're going to have to take the offset we get here. Then okay, we're going to have to, if we unpack the vector into its x and y, okay. Then if self.limits dot top, then x is equal to math dot min self dot limits dot top or x, and 0 is truthy, therefore in Lua, therefore that should hold. Even if we set it to 0, self, and then we've got self dot limits dot bottom, then x is equal to math dot max of self dot limits dot. That is because no one asked you, Siri. Sorry, self dot limits dot bottom is set to. Okay, so by doing this, we have now constrained x within those values. So if the top limit is set, we say that the minimum position of x has to be that value. Otherwise, and if the bottom is set, then we say the maximum value is the bottom. And then if self.limits dot left, then we want to set the oh god, no, I'm stupid. That's the other way around. So sorry, the y needs to be constrained by the top and bottom. And then the x needs to be constrained by the left and the right. And then we want the max there. And then self dot then self.offset is going to be equal to vector2.new x and y. What do we have here? What is Alright, we'll make the type checker happy later, I think, but if we run things now, okay, that's not what I expected. Line 43. So unpack should return 2 values. Okay. So something strange is going on here. Or I'm hugely misunderstanding something. So if we go to the debug, if we go to the debug console, so we can unpack this into 2 values. If I set 2 values to that, do I need to go? Is it for a case of brackets? No. Okay, back to the browser. I feel like we've already used multiple return values. Where are we? Here we go. Multiple results. Yeah. So can we not do that as part of the local? That is bizarre. But if that is how it's going to be, then if we do that instead, does that then set? So why still doesn't get a value? So if we have, well, if we look at our vector2 class, the unpack method, we definitely return 2 values. We return both the x and the y. When we try to assign, when we do the, it passes through the math. Ah. I think what we're getting is it's because the negation happens after. Okay, so the negation there was applying after the unpack. Oh, sorry. Yeah. So what we're seeing is this negation is applying to. Sorry, this negation here is applying to this rather than this. So what we need is to wrap that whole thing in extra brackets. And now we have two numbers. And then if we restart, yeah, these are getting set correctly now. Which means if we remove our bullet point and play, we get nothing. Okay, let's try that. That is unexpected. Let's give it an extra go. We'll breakpoint this time. So what do we have for x and y now? So x and y is set. So screen, yes. So position is 0. So the offset ends up being wait. So the next run. Okay, these are more meaningful values now because the position has been set. So the position is set to 400 by 300. Sorry. So the position is set to 400 by 300. And screen is set to 800 by 600 and scale is set to 2. So these are not set correctly though. They should be because we should be negating it. So left dot limit is sorry, I have flipped my mins and maxes. So this is the mins. Right. Yeah, because if we go past the left, so if left is set to 0 and we go past that, we will end up in as -5, for instance, and then we want it to constrain it to the 0. So therefore it should be the max on that, and then and then for the other side, if right is set to 100 and we end up at 110, we still want the 100 back, so that's the minimum. Okay, foolish mistakes, but fixable, and here we go. Okay, so We are no longer following the camera around. Okay. Why is that? So we end up 200 and 150, 200, 150. But that's for position 0. And then, okay, 400. We end up at 0, 0. Let's see what we've got. So we've got the position is 400, 300, and X and Y that we've got out is minus 200. Yes, sorry. So we want to negate this at the end because we're working in coordinates, and then we want to move it at the very end into being our how we move off. So if we restart now, let's see what we have. And if we go look at the game window, hey, and okay, so we're now constrained within the confines of the map. Okay, so we're confined within the confines of the map on the north, on the top and the left, but not on the bottom side. Interesting. So why are we not constrained on the bottom? So the position why is this not getting set again? So this is not getting, why is this not getting called as we move around? Okay, okay, so the breakpoint had just broken, but so we've got a 960 pixel wide, 640 there. So if we toggle that breakpoint for a second and move down to where it's failing. Let me toggle it back on. Okay, so the Lua debugger is not good enough to pause again there. So let's love.graphics.print. Oh no, because this is going to. Okay, let's print the. Print things into the console instead. So we'll go for the limit, and then x and oh no, y there, sorry. And then if we run that, so we have limits left, top, right and bottom, which is set to nil. And then it's a problem in our set limits call. Set limits. Wait. Are we not calling? Did we not call the set limits all? I'm sure. Yeah, camera, set limits to size.x and size.y. But somehow this is called first. Update should not be firing before load. That's that seems sensible. Oh, it's because we set position here. So this is done before the limits are in place. Okay. So we set the limit to x of x and y, okay. So that bit seems sensible. That bit seems sensible. Okay, yes. So, alright, so then here we go. It's only debug code, so it's messy, but it will work. And with that, we should be able to go down. And then if we, okay, so now if we look at our code, sorry, if we look at the values here, so yeah. So when we move downwards, hang on. Yeah, so I can continue to go down further than okay, so it's constrained incorrectly. not bottom edge. Top edge works because it's 0, but something else is going wrong in the maths for the other direction. So if we look at the values that we're getting out of these, the 374. Effectively, we expect it to be sort of constrained around here. Yeah, it's about halfway. Oh, the scaling is in the wrong place. Okay. Because we don't want to set the position by the scale. We want to scale the screen. This is a I think to some extent this bit needs to come out. That's going to throw. So this scale factor needs to come out. We need to look at being halfway across the screen. So I feel like that will give us the right x and y's to work with, but then we need to reapply the scale before moving onwards. But we don't want to add. We don't want to just divide x because we don't want to change the position part, just the screen part. I'm actually quite stumped on this bit. So we want to constrain. So it's the constraining and centering is conflicting. So the constraining and the centering are both conflicting with each other. So we have the position, and then the screen value we have is in unscaled pixels, but this position will be in scaled pixels. So this should, in theory, be right. What was I echoing out here? So we've got the position itself. we've got the position of the camera. Which will be the top, that will be the top left of the camera. So X is the top left of the camera, position of the camera. Position, and Y is X and Y are the top left position of the camera. The position is the actual position of the camera. And this should be the maximum position that the bottom edge can pass. Oh. Wait. No, it's not a case of the X and Y. So, okay. So we need to keep a reference to this value here. Okay, so we're going to have our screen. We're going to divide it by 2 here. Then when we calculate the other edges, we want the right, if the so we want to constrain this to half the screen, because we're looking at the top edge. So we want to subtract the size of the screen off of. No, we want to subtract the size of the screen off of it, I think. Okay, so if we run this again, window, we come down, okay. Okay, no, that is working. What we're seeing is a problem with the fact that I have the tile map offset by half a tile. So if that is not a problem about the logic in our camera anymore. That is a problem here. In that we want to do we want to take we effectively want our map to be one tile. Oh, sorry. So if we look at our if we come back to our main where we set up the limits, we effectively want our map to be one tile short. Minus vector2 new sorry, 1 1. Yeah, so we want to constrain the size of the map. We want the map to be one tile shorter than it is, because what we're doing is we're taking our tiles and we're then just offsetting them by half in order to do our sort of terrain mapping stuff. So now if we run again, we should actually now be confined within the confines of our map. So now, yeah, so here we go. So now we have our working camera, and it can't run off the side of the map. I guess then the next thing we probably want to look at for today, and then we'll probably call it for this week, is all of these grid lines that have appeared. So I have a theory on where they have come from, and for that, let's go back to, let's go back to our edited tiles. So this is on a white background at the moment. So if we document transparent background, there we go. So now we've got a transparent background on our tiles. And then if we export, this again, so we save this to tiles, replace. Then if we run our game again, that is not what I was expecting. So somehow we're rendering gaps. There's some real oddities with some of these tiles as well when they're zoomed in. Let's see what zooming in further does. So just setting the background to transparent didn't fix things. We've got our assets here, our tiles. Oh wow, actually that is okay. Some of that is actually that things are not exported cleanly. But also we're getting this weirdness in the pods. Is that black line from the editor, or is it in the file? Let me have a quick nose in the file system. Data, assets, images, tiles. Okay. So no, so the transparency is there, but things are not being picked up correctly. This is let's try pushing the scale to something. Push the scale to something extreme, then we can see what we get instead. So now if we're on it, okay. So is the gap increasing as the scale increases? I think it is, right? Zoom, if we go to the extreme, sorry. So it's not bunning the tiles up to each other, correct, 100%. Which means I think we're doing fractional offsets. Somewhere in our code we've got fractional offsets for the drawing instead of booleans. So to so to look at that, where would that be? So I guess when we look at our, well, the call is here. This is where it's going to be going bad. But what do we have? So these are all solid values. So what do we have for the quad? The quad itself is probably set wrong, which means that so let's see what we get if we go. So we've got quad value. These quads are stored outside of. Yeah, these are stored outside of the Lua runtime. These are in the C code that the Love engine is managing for us. So we'll need to run a method on that. Sorry, let me hide the game mode. Okay, so yeah, so these quads are what's known as user data in Lua, and it's stuff that's passed into the Lua runtime from outside. So they're a bit, we can't really drill into them much, but we can poke at them a bit. So if we have a look at the love.graphics, this has the quad, and yeah, so let's have a look at some of the methods on this. So we have we can call get viewport. So that's giving us some whole numbers. We get the texture dimensions. Those are also whole numbers. Hang on. No, I think I think I know what's going on. Oh, sorry. Let's go back to our browser. So what we need is in here. We need to so we've got anti-aliasing going on here, and it's anti-aliasing between the transparent and the edge. So we need to figure out how to stop it from doing that to our we need to work out how to stop it from doing that to our textures as it draws them. So how the image wraps inside a large quad, vertex, stencil, stack type, point type, pixel form. No, I don't think that's what we want. No, that's the... Okay, mini-map. Mesh draw mode. Line style. Is it draw mode? Filter mode. Okay, this, yes. Okay, yeah, so we're getting linear, and what we need is nearest neighbor, I think. Oh, hang on. So, hang on, what was that? That was the filter mode. Yeah, so we need, okay, so set default filter, set filter. Magnify, anisotropy. What is this? The maximum amount of... okay, filter used when minifying texture, rendering it smaller on screen than the size in pixels, and then, okay, so we need to go into our textures as we load them. Where are we? So as we load our textures, it's part of the texture atlas. No, even before that, I think. We need to set the filter. So I think this is in it. Texture atlas. This takes the actual file. No, this takes the texture. So I think as it's passed in, then we want to go texture.set filter, and we want both of these to be nearest neighbor. So then when we run things, okay, so that's no longer drawing the lines. We also want to go and check out, sorry, we need to fix our, right down at the base, we want to look at our zoom factor. So now if we run again, okay, cool. I need to have a look at the base file because it looks as if there's some subpixel offsets or something going on in the original file, but otherwise it seems to be drawing quite well. Sorry, oh, game window, yeah. So sorry, so now we've got rid of our lines. There's still some bits gone. This is actually in the PNG though, so I need to work out what's wrong with our source file and why that is messing up. But otherwise, it seems to be working okay. So I'm going to assume that I did something stupid and drew with like transparent through some transparent pixels, or that there is a ever so slight pixel pixel offset, like subpixel offset in the base file, and that's causing it to export uncleanly. But otherwise, this is I think this is a good place to stop. Though I'm seeing some visual artifacting as we move around. Every now and then I can see I'm not sure if it's coming through on the stream, but I can see sort of some visual artifacting. Ah, there we go. It just happened. Yeah. So I can see something I can see some banding happening as we're moving around. So I'll need to have a look. We'll need to investigate that. That maybe hopefully fixing the tiles will prevent that. No, actually no. Fixing the tiles shouldn't be able to fix that. But let's, out of interest, have a look at what things look like at 3 times. That's too bad. I think that's it's maybe a nice nice resolution for. I know 4 is too much. Four is definitely too much. 3 is all right. I think 2 is maybe a bit too small, but 2 is also good. I think 2 is maybe we'll leave it at 2 for now. But yeah, so okay. So we've now got our working camera. We've got a working camera. It's constrained within the size of our. It's constrained within the bounds of our map as well. I think we've ironed out a load of kinks in that as well. So we've set that up quite cleanly. It would be nice to find a way to have it update without needing to. It'd be nice to find a way to have it update without it sort of needing to have the reference to things. We might even be able to just pass because position gets overwritten. Well, we'll have to find a way to get this camera position, set position, keeping reference to the player and things out of things. It's a little bit messy at the moment, but we have to use two global variables to make it work. It'd be nice to get that down to just the camera. Maybe we can register some sort of callback with the camera or something and then the camera can just update here and it can get the position itself. That's maybe one thing we can do, but it feels like a good place to leave it for today. So thanks for joining. If you like the video, give it a like. If you want to see where we end up in this adventure in game development, then give the channel a subscribe, hit the notification button, and I will be back next week. And if you are up for some some non-developer related streaming, I will be streaming Minecraft Skyblock on my other channel on Wednesday, starting slightly later than the normal. normal time about 30 minutes later because Tuesday is my birthday and I will need a little bit more time to how should we put it? Put myself back together in the morning. So, thank you for joining, and hopefully I will see you all in the next one. Bye.